Hello, welcome back to the channel. Apologies for the delay in getting new videos out. We've been very busy over the past few months. We've had a big move around of workshops, etc. So you can see we've got a nice new workbench. What we're looking at today is a Bell Amy Jukebox amplifier that a customer has bought in from his Jukebox. Excuse me. Now, he'd bought this restored in inverted commas. The mechanism's been worked on, and this amplifier has been royally bodged. This isn't the original transformer, but it looks like it might suffice, but it needs some work to it. I mean, the top side really doesn't look that bad. It's just old and cruddy because it's just dirty. But I'll just pause it and spin it over. So here we are on the underneath of the amplifier, and to say it is Bodge-tastic is an understatement. It really has been. I mean, I know there's people who have a go, but this is just awful, dangerously awful. I mean, you can see that we've got burnt wires here. Try and find something to point with a pen. So you've got your burnt wires here. I mean, this soldering here is delightful. I don't know what these are doing. I mean, it's amazing that the customers sent it to me because apparently it's got low output. I'm surprised it didn't blow the place to pieces. You've got some quality joints. I mean, these are just bodged on here with some old earth wire, copper wire from some 2.5, sort of strapped around here. Components just dangling, with HT on, got probably 300 or 400 volts, if not more, on some of these components, just dangling around with no insulation. Up in this section here, we can see there's lots of original condensers, capacitors that haven't been replaced, and these little brown hunts are notorious for. Well, you can see one here. Look, it's split to pieces. I had to get a bit more light in there for you. And these are notorious for causing problems, but that one's completely split. Albeit this is just sort of like tone correction up here for the different records on the jukebox. So yeah, I mean, this wire's not connected. I don't know what that's doing. Where he's been in there with a soldering iron, all the wires have been melted. It's a proper bodge, and that's fair enough. Someone's amplifier is going to play with it, but it's come to us now, and we need to bring it up to some sort of standard. So there's not going to be a massive amount of sort of what we're doing in this video. What I shall do, I'll just sort of bring you back in every time we've sort of gone through a stage. What I'm first going to do is just sort out the power section here. We've got these resistors that are, they've obviously just been getting far too hot and have cooked these wires here. I'm being a little bit careful not to move things and break them off, because it obviously is working at some point at the minute. Luckily, I've been able to find some. It's not exactly the right model. There doesn't seem to be the data for this model, but this is as near as damn it close for me to be able to work out what's going on, because we could do it without the schematic, but it'd take 10 times as long working out what all the values should be. So first things first, I'm going to start working on this, tidy that transformer up, get rid of all this horrible mains cable that's been used for sort of jumper wires. There's nothing wrong with it, but I don't like it. It doesn't look very nice when you've just got brown and blue cables dotted everywhere. Bearing in mind this sort of thing is going to get fairly hot, so we'll replace that with some nice silicone flex, so it's nice and silicone wire, so it's nice and flexible and not going to matter if it gets a bit warm. So come with me on this journey of sorting this amplifier out, and next stage you'll see, we'll have sorted this out. Okay, so I've had a look at this mess that is under here. There was a resistor that shouldn't have even been here, that was basically just joining these two together on the capacitor. So I'm making a new little resistor network up on this piece of tag strip, which will replace this one. This is too far gone, like it's completely cooked. For some reason my phone doesn't want to focus, but yeah, so I just want to make a point, because obviously when these do get quite warm, so we like to make a nice mechanical joint on there as well. I've got it, you can see, wrapped around, just gives a bit of protection just in case it was ever to get too warm, and we don't want things floating around. So anyway, that's all made up. This these resistors are part of the filtering network, and they sit between the capacitors, which on the diagram is just here. So you see you've got 4 20 microfarad condensers there. This little network here makes up the 15k, and there's a 5k in here. So that's what we've got down here. So I'm now going to get that fitted back in here and work out some of those other awful wiring, and we'll get at least this first capacitor up here all connected and some of this wiring tidied up. So I've taken that resistor network out. This is the rectifier here. This is the rectified DC that comes out here to the muting relay, which is up here. And obviously when there's, this turns the HT off so you don't get any noise when it's not being used. That comes back on this thin red wire down to this resistor, and it's connected there. But as you can see, if I take you around there, it doesn't get connected anywhere else. It stops there. So something must have pinged off or broken off as it was coming in, because it wouldn't work at all without that being connected. Because this is the main HT feed from the rectifier. So that's obviously going to be replaced with a new little network we've got going on down here. But while I was here, I thought we'll just have a quick look at the bases of the output valves. We've got a couple of, which were 6L6s originally. They're going to go in here. I think it's KT77's fitted at the minute, but it's a fairly close match. Then again, you can just see that the insulation, this is a high hours unit. Many jukeboxes are. They're in coffee shops and cafes and was blaring away for 6, 7, 8 hours a day. And even if they weren't actually having anyone put any money into them, they often had autoplay and that sort of thing. So they got cooked. So this one's well and truly cooked. You've got some screen feed resistors here that don't appear on the diagram, but this is they're very slightly different. These look very, they're both shattered. They're completely knackered. So they look quite small for screen feeds as well. So I'm going to increase those and get some decent power resistors in there for those. You can see we've still got some of the old wax and paper type resistors, capacitors in. So this one's got to come. These will all get changed. So next job, I'm going to refit this panel in here, just inspect the wire and sort of retouch up what's ever happened with here. This is where the heaters are coming in. So it's been snipped off there. I have no idea what that's doing. But we'll replace the heater wires back to the transformer, tidy this base up, just double check all the solder joints, and get the little network back in. Right, so I've rewired all the main wires going to the output valves. They were in a pretty shocking state, as you remember. You can see all the new wires going through here, insulated now, so they don't cause any issues. The coupling caps here to the audio output to the valves. Obviously, I've still got to deal with this. I've still got all this funny earth kicking about here, which is going. You can see I put a new earth rail in there that's tied down. So next job, I'm going to get rid of all these horrible earths, work out what's going on up here. We've got some, I don't quite know what that capacitor is doing. There's another thing up here that's just dangling in midair. But you see, it's a lot tighter than it was. It's never going to be perfect, but it's much better. But now I've got this all wired up. I've just got these 2 wires that head off to these are the screens, which I'll put the new screen feed resistors in there. And these are the wires that go into the output transformer, which I'm going to attach, and I'll get that little resistor network in there, and that'll be this area reasonably cleaned up. So the resistor tag is in. Some of these haven't been soldered yet because I've got wires to take to and from them. The new earth bus is in, as you can see here. All the wires down to the rectifier. This is all stuff that isn't used. What we're going to do now, you can see there's a hole in the chassis. It's where this new electrolytic capacitor needs to go. Now the hole, when the chapper fitted this, there's nothing wrong with the capacitor. It's just been fitted in a tiny hole, so the legs didn't come through the hole here. So I'm going to make the hole bigger using a QMax cutter, which is designed for the job, which basically is this sort of cutter which cuts through steel and aluminium. You put it this piece one side of the chassis, this the other, and pull it together with the bolt on top, and it makes a nice clean hole. no jagged edges to either catch your fingers on or any components. So that's what I'm going to do now. I'd love to show you what I'm doing, but it's a bit tricky. I'll need every single hand I've got plus my feet and everything else to get it to go. So I shall come back in a few minutes and show you what it's like with the new hole. So just quickly, while I've got the Qmax cutter fitted, you can see it's fit a ring spanner or any spanner to here. Turn this. I can't turn it with just one hand because it's obviously quite thick steel, and the cutter has been pulled up from the bottom. You get a beautiful hole. I'm assuming you can still buy Qmax cutters. These are a very old set that I was left by an oil engineer of mine who used to work for us many years ago, who died. But yeah, these are all different sizes. I've got square ones for doing transformers, and they're if you see these anywhere and you're into sort of vintage electronics, chassis especially, see if you can get hold of some Qmax sheet metal punches, because they're awesome for doing exactly what you're doing now. Having to make that hole bigger with a saw, it'd be a mess. With a hole saw or a file, even for hours. This is a very quick and neat way of doing it. So as you can see, when I got a lovely clean hole, no sharp edges, and this has now been pulled right through. If I undo this with this fingers, you can see this just moves in and out. And inside here, when I get it out, keep turning, and you can see there's these teeth, and just inside there you can see the piece of metal that's been cut. Right, so we can get the new capacitor mount. Ignore these holes; these have been drilled for a smaller capacitor, so I'm just going to re-drill those for a different mount, and then we'll get the capacitor in. So things have progressed a little bit more since last time. You can see we've got a few more resistors which have all checked out in poor, or it's just the fact that I've had to sort of rearrange the way the circuitry is laid out because of the way I'm wiring things up. I have no idea what it was like originally. I'm going to assure you it wasn't just on pieces of copper wire floating around like this. So anyway, I've done all this, but you can see the capacitor is in that nice hole it cut with the Qmax cutter. That's done. This one is also in. I've just got to finish wiring up this capacitor. Put another earth rail in for things to pick up off this side. So we've got like a common earth for all of this. Link them together, and we won't be too far away from powering things up then. We just need to concentrate, as I mentioned in the beginning of the video, on just replacing all these old brown Hunts capacitors, and just double checking these resistors. This is all part of the equalization network. See, we've got one left of this. I mean, there was nothing wrong with these disc capacitors. These are fairly bulletproof, but we're just tidying things up. And it was mainly because the insulation has started to fray, and it was just that there were long legs, which could introduce sort of hum and that sort of thing. So we're going to try and shorten them all down as much as possible. We've got this to do. You see, there's a couple of capacitors here that I need to replace in. So I'm going to crack on and see you back in a while. So the day's ticked on, and things have moved on also. New earth bus in here, so that's all done. We're pretty much done on this part now. Just about sort of just moving things and tidying them up. It's quite tight in here for components because it is point to point, and it's all sort of straight on the bottom of the valve holders, purely because of the gain involved. So you don't want too much hum and stuff, so they've not taken wires off where they don't need to tag strips, etc. Anyway, so they're all in there. A couple of Mullard mustard condensers just to isolate off the last valve before the output bottles. All I've got to do now is there's something gone funny with here. This resistor, I've just popped it in there so it reminds me that it shouldn't be there more than anything else, because obviously I'm working to someone else's bodgins. There should be a volume control from here to here, but they've just stuck that in there. So now I know that doesn't need to be there. I should take that out and replace it, because it should now be connected to these pins up here, which is going to be the volume control. So just a few more condensers to do up in this point. All these were gone well high. These were 150k. They'd gone in excess of 300 each. So they've been done. Little capacitor under there been done. Just got to sort this out. A bit of a sort of bodgy thing just floating around in midair. So we'll deal with that tomorrow. But yeah, I'm going to call it a day for today. and come back to tomorrow. So we're just about done on the underside of the Bellamy chassis. You can see we've gone through all these capacitors and resistors. Some have been changed. We got rid of that dangly thing going across the top and put a bit of terminal tag strip in there for that to hold that nice and tidily. So next job really, I've just got as a side note, the output transformer, albeit ultralinear, it is obviously for a hi-fi, not a jukebox, so that's been replaced at some point, which is what I feared. So I can't do a lot with that until I get it on. Then we'll test, see what's coming out and what's what on these, because it looks like there's two outputs on at the minute. But we'll work that out. But I don't want to connect anything up here yet, because it is only going to go into a single speaker inside the jukebox. It doesn't really matter. It's not like it would have been if it was in a cafe or this sort of thing. On here you've got multiple outlets. You can see on the diagram here, various tap-ins on the output transformer, so you could connect X amount of speakers in series and parallel and this sort of stuff, but that won't really matter for us, so we'll work out what needs to go on here. So the next job we need to do, just connect up these wires you can see going through here up to the transformer, and then we'll start applying some power and test them what we've done. Okay, so we're pretty much ready to get some power onto this. I've gone over and double checked all the connections, because obviously when you're reworking something like this it can be a bit tricky and easy to miss something. But I've gone over it 2 or 3 times now, so I'm pretty confident that most things are in the right place. One thing I haven't fitted is obviously the heaters are going to want some sort of earthing at one point, but the diagram shows a hum balancing pot, so I've got a 1 watt resistor in there for that, otherwise it'll hum really badly without that. Other things were to look up here, I've just worked out we've got 2 tap-ins on this transformer, so we've got ourselves across one of the transformer taps. This is just an earth. Here's a wind-in, and here's another wind-in there. Also got a couple of temporary leads just hooked up here that aren't attached yet for the negative feedback. Just here is a little feedback network. You can just see it in there. Focus on there. Just in here, this little chap is a little feedback network. So we can do that while we're looking together. So what I'm going to do, dim bulb it to start with, and get the power on there. So my bulbs are up there, so I can see, and get the meter on here. So she's warming up. Up go the volts. Current is currently at 130 odd volts on the AC, and it's only drawing 21 watts. So obviously the valves are heating up now, so the voltage is just going to start to drop. So that's settling around about 122. So obviously, right, we need to put another bulb in circuit just to bring it up a little bit. So we're sitting at 166. That becomes the HT now, 235. I can hear a good hiss from the speaker. I've got to be very cautious because this has got an enormous amount of gain, this amplifier, designed for a pickup from a jukebox. So I'm not going to touch this because this is the input up here. But if I go near it, oh yeah, I can just touch it because I'm on low volts. You can barely hear me over that. That's super. That's working really well, and it's only on 150 volts. So what I'm going to do, bring another bulb in. So now we're sitting up at 210 volts. Oh yeah, I can hear all the valves coming. Now I can't get near it. Just as I'm getting near to it. Right, there's tons there. So what I need to do is just ascertain the negative feedback. Now there's professional ways of doing this, or there's just a quick way of doing it, and I'm going to do it the quick way, which is connect one of the wind-ins. This is how it's connected, but it's just, this is either going to work or it's going to howl. So we go that one to there, and this one's connected to the feedback network, and this is go to the secondary of the output transformer. That's the wrong way around. It's farting. So connect that way to there, and that one to there. Perfect. That's got rid of a lot of the noise. Still got that there, and we're running low volts. We've got 206 volts going in, and I've got 300 volts on there. So it's all looking pretty good. So that's pretty amazing for the first time, really. It never normally happens. Oh, no, one thing I did need to point out, which I didn't show you before, I thought I'd better just double check the windings from the transformer, because I'd made an assumption that whoever had fitted these before had got these windings around the right way. And luckily I checked, because we had, because this is an ultralinear amplifier, what they'd done, whoever it was, put some light on here for you, what they'd done is they'd connected these two windings around the wrong way. So the one that should be going to the grid was going to the anode, or plate as you call it abroad, in the States, and the plate was going to the grid. So they were back to front. So I'm glad I checked that, because I probably would have been particularly happy about that. Right, so I'm going to get that hum balancing pot fitted, which is just dangling down here at the minute. And then we have some proper testing. Turn it off. Yes, we'll just do some testing, but I'm just going to obviously just wire these transformer windings from the output transformer in as well, and wire in the negative feedback. Here's the little hum balancing pot that I'm going to use, little 100 ohm. Now it did have a shaft on it, but I've just taken the little angle grinder to that and chopped that off, because I don't really want the customer actually fiddling with this particularly. It needs to be readily accessible if they change valves, etc. But so I've just cut a slot in that as well. So I'm going to drill a hole in the top of the chassis. There's loads of room on top. I'll put it up here somewhere, and I shall fit that in, and then we'll be able to balance the heaters so they don't hum. So finally, you get to see the top of the amplifier. You can see all the valves and the replacement electrolytic condensers here. One job I've got to do is, I just noticed this has been held in with a couple of self tappers, which I don't like, because they're just ready to rip your fingers when you go and poking around inside. So this was fitted before me, so I'm going to change that to some nuts and bolts like so. Here's the little hum neutralizing pot, just fitted in there, so with a little screwdriver turn on top. I've got to put the mains wiring on, which I'm now going to do. As you can see in here, it's just sort of under the tapes. I just didn't brush as I was working on the bench. All the windings for the valves, from the transformer are there. All a nice, heat resistive silicone wire. Output valves, KT77s, and the rectifier valve, which is a 5U4. So what I'm going to do now is just get the mains wired up. I'm not going to sheet in that, because it's just basically wires going in through the fuse to the transformer. There's no switch in, because that's all controlled by the actual jukebox itself. Just one more thing here along the back here is where you've got the speaker outputs, output for the volume control and the muting relay. So let me get some mains on it, and then we can have a final look. Okay, so to wrap this video up, here's a quick look at the top of the amplifier. As you can see, I've fitted a board there to stop people from... it's going to be inside a jukebox. I'm just going to touch it, but it's nice when you're working on things not to have a mains floating around, just in case you brush your arm against it or something. So there's the actual chassis ready to go back. Got a temporary volume control just fitted across here. This is the speaker output now. So yeah, just play a little bit of music. So you've got the, to be very bassy, because obviously it's designed for a cartridge. Yeah, it's very loud. It's making the speakers bounce everywhere, because obviously it's designed for a cartridge, not a output from the computer. So next job is to get it back to the customer. He's going to fit it into the jukebox. But what I might do is do a follow-up video, a part 2, if the customer is okay for me to just do a follow-up with this back inside the actual unit itself. But anyway, thanks for watching. I know it's been pretty much just a video of what we've done, not how we do it, because there's dozens of videos of people replacing capacitors and that sort of stuff on YouTube, so we just like to sort of show you what we do. And you can clearly see those valves glowing beautifully in the back there. There's something nice to look at. I hope you find it entertaining, enjoyable to watch, and we'll see you on the next one.